Good morning, students. Today we're going to look at section 9.4, which is on polar coordinates. Here we go. Right. So this slide here basically just shows us what a polar coordinate is. We're used to the rectangular system. This is a review, but basically instead of giving you an x coordinate and a y coordinate, you're given a direction angle called theta, and you're giving a radius or a length. And typically, you're going to see polar coordinates written in this form. I got to turn my pen on here. You'll see it written like this, r theta. Instead of x, y, it'll be r theta. Here are conversions, which again, this is review. If you need to convert from polar to rectangular, x is equal to r cosine theta, y is equal to r sine theta. If you need to go the other way around, to get your theta, you're going to use tangent theta equals y over x, and the radius squared is equal to x squared plus y squared. All right, so our first example here is we're going to convert a couple of these from polar to rectangular. So the first part here, we notice that for part A, we've got r is equal to 3, and we've got theta is equal to negative pi. So that means that x is going to be equal to r times the cosine of theta, which is going to be 3 times the cosine of negative pi, and that of course is negative 3. For y, it's going to be r sine theta, which is going to be 3 times the sine of negative pi, and of course that's 0. So to put that into rectangular coordinates, that would be negative 3, 0. The second one you do the same way. I'll let you guys try this one at your own pace. I ended up with an answer of negative root 2 over 2, comma, root 2 over 2. Same idea. All right, example 2. I am not going to spend a lot of time on graphing polar equations. I would encourage you to investigate that on your graphing calculator. So the first one is what is the graph of r equals 2? Well, r is a radius, so basically it's just saying all the points on the polar graph with a radius of 2. So that's of course going to be a circle with a radius equal 2. So that circle is the equation for r equals 2. For theta equals pi over 3, well, that's going to be all the points where the angle is going to be pi over 3. So that is roughly a line going through the origin with a slope of square root of 3. This is m. Sorry. Why or how did I get the square root of 3? Hopefully you can use the definition of theta to figure that out. Okay, so finding derivatives in polar form is a little bit more complicated. The book does a derivation. I'm going to kind of skip over that, and I'm going to tell you right now, here's the formula. It involves the product rule of the top and the bottom separately, but that's the rule. For dy dx, it's going to be f theta cosine theta plus f prime theta sine theta divided by negative f theta sine theta plus f prime theta cosine theta. So now let's look at an example of this where we're going to try to find the horizontal and vertical tangents of this particular curve. So they give us r, which is the same thing as f theta. So the first thing you want to note is the f theta in the formula is simply the equation r. Therefore, f prime of theta is going to be the derivative of this. Well, 2 times 1 is 2, and the derivative of 2 is 0. And then 2 times negative sign is negative 2 sine theta. So then the derivative of that would be negative 2 cosine theta. So now we have our f theta and our f prime of theta. So to find dy dx, we can start to just plug that into our formula here. So we're going to do, first of all, 1 minus sine theta times the cosine of theta, and I'm just using the formula here, minus, 2 cosine theta sine theta, all of that divided by negative 2, 1 minus sine theta. By the way, that's negative f theta, times sine theta, plus negative 2 cosine theta, times another cosine of theta. This is cosine of theta. By the way, my notes are posted on all these. If you can't read these very well, I apologize. So at the point 2, 0, what would theta be? Well, theta is 0. So you're going to plug 0 in for theta, and it will turn out that the derivative, dy dx, evaluated at theta equals 0, turns out to be negative 1. That tells us that over here at the point 2, 0 on our graph, the slope of that tangent line, the slope of that tangent line is negative 1. And at the point 4, 3 pi over 2, clearly theta is 3 pi over 2, dy dx there turns out to be 0, which means that down here at 4, 3 pi over 2, this slope here is m equals 0. So I would encourage you to go back and check my math, my work, if you will, on that derivative. But you will find that the slope at 2, 0 is negative 1, and the slope at 4, 3 pi over 2 is 0. All right, the last concept for today is Theorem 911, which basically tells us how to find tangent lines at the pole of a polar equation. And the theorem basically says that if f of alpha equals 0 and f prime of alpha does not equal 0, then the line theta equals alpha is tangent at the pole. So this is called a rose curve, and its equation is given right here, r equals 4 cosine theta. And it says sketch the graph, which I've kind of already done that for you. It's there on the slide. And we're supposed to find the tangent lines at the pole. Oops, and I didn't put a t in there. That should be at the pole. Okay, so in order to do that, we got to consider that we want r to equal 0, and we want r prime to not be equal to 0. So when would, first of all, let's, oh, and I didn't save this either. This is supposed to be a 3 in front of that. That's supposed to be a 3. This is r equals 4 cosine 3 theta. So let me correct that. I apologize. That is r equals 4 cosine 3 theta. I'll make sure I get that updated on my notes on Canvas. That's the equation. Okay, not this one. So when is cosine of theta? When is cosine of theta equal to 0? Well, if we're talking about from 0 to 2 pi, there's only a couple of places where that happens. I think they are pi over 2 and 3 pi over 2. Remember, cosine is equivalent to x. So now my question is when would 4 cosine of 3 theta equal 0? And again, if we're going from 0 to 2 pi, it turns out that there are 6 locations. I'm only going to list the first 3 though. The first one is pi over 6. The second one is pi over 2. And the third one is 5 pi over 6. Now there's actually 3 more from this interval, but it turns out that this curve can be generated completely from just going from 0 to pi. So you only need the first 3 of those instead of the first 6. So it turns out that, for example, let's do pi over 2. Pi over 2, well, what is that? Well, that would be the line. Remember, our theorem says that theta equals alpha, so theta equals pi over 2. Well, that's the same thing as saying theta is 90 degrees. So guess what this is right here? This line right here. This is theta equals pi over 2. And guess what that is? That is a tangent line and a pole. You can probably guess what this one is right here. This is the line theta equals pi over 6. That is also a tangent line through the pole. And then finally, you can probably guess what this last guy is. I didn't do a very good job at graphing that. That would be the line theta equals pi over 6. Sorry, this one went a little bit long today, guys. Have a good day.